So today's video is practicing on each type of systems solving, the elimination method, substitution method, and chart method. So the elimination method, the goal is to get one of the variables to cancel out and eliminate itself when you add or combine the equations. So I see a positive 2q's and a negative 5q's here, which those are opposite signs. So multiplying each term in the first equation by 5 and each term in the second equation by 2 should give me negative 10q and positive 10q. So 5 times 3p's is 15p's. 5 times 2q's is 10q's. And 5 times 1 would give me 5. Multiplying each term in the second equation, I get 4p's, and negative 10q's would give me negative 24. Combining those equations, the q's are eliminated. So I get 19p's equals negative 19. Dividing by 19 on both sides, I get p equals negative 1. Substituting that back into the first equation, 3p plus 2q equals 1. 3 times negative 1 plus 2q's equals 1. So I'm solving for q now. I have negative 3 here, so if I add 3 to both sides, I will get that 2q's equals 4. Dividing by 2, I get q equals 2. So I believe the answer is p is negative 1, q is 2. I would like you to do the check for this, so pause the video. Please write the original equation, both of them, the original given equations, and check that p is negative 1 and q is 2. So please do those checks. Method 2, substitution. And nicely, this equation is solved for one of the single variables, b equals. So I'm going to put this expression into the first equation for b, because b equals that. So that's what substitution method is. Substitute in the variable into one of the other equations. So 5a minus 2, yes, I'm going to have to distribute. b is 2a minus 2. It's that expression, has to equal 8. So 5a, negative 2 times 2a's is negative 4a's. Negative 2 times negative 2 is positive 4, equaling 8. So I get a plus 4 equals 8. Subtracting 4 on both sides gives me a equals 4. I'm going to substitute that back into the second equation, b equals 2a's minus 2. And I get 2 times 4 minus 2. So that's 8. 8 take away 2. b is 6. Again, I'm going to leave the check. Please write the original equations in your check. And check that a equals 4 and b equals 6. A equals 4, b equals 6. And the third method that we did, that we're going to practice, because yes, we do have a little quiz coming up on this, is the chart method. So I'm going to make a chart for 2x minus y equals 5, and a chart for 2x plus y equals negative 1. Well, the easiest values to choose for x are 0 and 1. So I'm going to start with those first. Putting 0 into the first equation, 2 times 0 would be 0, minus y. So 0 minus y has to equal 5. Well, that answer has to be negative 5, because 0 minus negative 5 does equal 5. Okay, putting 0 into the second equation, 2 times 0, that's 0. 0 plus what y would equal 1? Well, it must be, negative 1 would be negative 1. So they are not the same value. They don't have the same y-intercept, 0, negative 5, and 0, negative 1. So I did not find a simultaneous solution. Let's check x equals 1. So 2 times 1 would be 2. 2 minus what value gets me to 5? 2 minus negative 3 would equal 5. So when x is 1, y is negative 3. And in the second equation, 2x plus y equals negative 1. Oops. Putting in 1 there, I get 2 plus what y would equal negative 1. Oh, y equals negative 3. So I found a simultaneous solution. These two linear equations have x equals 1, y equals negative 3 working in both of those equations at the same time. So again, I'm going to leave the check for you. X equals 1 and y equals negative 3, or we could write it as the ordered pair 1, negative 3. I'm going to leave those checks for you to do. And that's it for today.